Hello, students. In this video, we're embarking on an exciting journey into the world of atoms and their tiny building blocks known as subatomic particles. Ever wondered what everything around you is made of? Let's explore the amazing components of atoms: protons, neutrons, and electrons. Atoms are the fundamental units of matter, and they are composed of three primary subatomic particles: protons, neutrons, and electrons. First, let's talk about protons. Protons are positively charged particles that reside in the nucleus, the central part of the atom. Each proton carries a charge of about 1.67 into 10 raised to power minus 19 coulombs. The number of protons in an atom is known as the atomic number, which determines the element's identity. For example, if an atom has just one proton, it's hydrogen. If it has 6 protons, it's carbon. Protons also contribute significantly to the atom's mass and are held together in the nucleus by a strong force. Next up are neutrons. Neutrons are neutral particles, meaning they have no charge at all. They are also found in the nucleus alongside protons. Neutrons have a mass similar to protons, about 1.67 into 10 raised to power minus 27 kilograms. They play a crucial role in stabilizing the nucleus by counteracting the repulsive forces between the positively charged protons. This balance is vital for the atom's stability. Now let's dive into electrons. Electrons are negatively charged particles that orbit the nucleus in regions known as energy levels or electron shells. Each electron has a charge of 1.6 into 10 raised to power minus 19 coulombs, but its mass is much smaller than that of protons or neutrons, about 9.1 into 10 raised to power minus 31 kilograms. Electrons occupy different energy levels, with the closest to the nucleus having the lowest energy. The outermost level, called the valence shell, contains electrons involved in forming chemical bonds. Comparing these particles, protons are discovered by Ernest Rutherford, electrons by J.J. Thomson, and neutrons by James Chadwick. Protons carry a positive charge, electrons have a negative charge, and neutrons are neutral. Electrons orbit outside the nucleus, while protons and neutrons reside inside it. Protons and neutrons contribute significantly to the atom's mass, while electrons determine its chemical properties. The discovery of these particles led to new models of atomic structure. Originally, scientists believed atoms were indivisible. However, new models were developed to explain how these particles fit together. J.J. Thomson proposed the plum pudding model, envisioning the atom as a large positively charged sphere with negative electrons scattered throughout, like raisins in a pudding. This model suggested that the positive and negative charges balanced each other out. However, it couldn't explain why some particles deflected during experiments or why atoms were stable. In 1911, Ernest Rutherford introduced a new model based on his gold foil experiment. He discovered that most alpha particles passed through the foil, suggesting that atoms are mostly empty space. However, some particles bounced back, indicating the presence of a small, dense nucleus containing protons. Rutherford's model depicted electrons orbiting this nucleus, much like planets orbit the sun. Niels Bohr then refined this model in 1913 by proposing that electrons orbit the nucleus in fixed paths or shells. According to Bohr, electrons exist in defined energy levels and can only occupy specific levels. They don't spiral into the nucleus, but instead move to higher levels when gaining energy and return to lower levels when losing energy. Understanding electron arrangement is crucial. Each energy level can hold a certain number of electrons, described by the formula 2n², where n is the energy level. The outermost energy level, or valence shell, typically holds a maximum of 8 electrons. Electrons fill the lower energy levels first before moving to outer levels, as described by the Aufbau principle. Valency, or the number of valence electrons, determines how atoms bond with one another. Atoms tend to gain, lose, or share electrons to achieve a stable configuration with 8 electrons in their outer shell, a concept known as the octet rule. Finally, we have the atomic and mass numbers. The atomic number Z indicates the number of protons in an atom's nucleus and defines the element. The mass number, A, is the sum of protons and neutrons, helping to calculate an atom's weight. Isotopes are variations of an element with different numbers of neutrons. For instance, carbon-12 and carbon-14 are isotopes of carbon. Isobars are different elements with the same mass number, like potassium-40 and calcium-40. Isotones are different elements with the same number of neutrons, such as chlorine-37 and argon-38. Understanding these particles and their arrangements helps us grasp the fundamental nature of matter and the universe. Now, here's a question for you. What is the number of protons in an atom's nucleus called? Please share your answers in the comments. The complete curriculum for 9 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.